Hello everyone and welcome to a brand new tutorial on how to create Minecraft in 2D. Today we are going to create something truly epic. We are going to create, as you probably have seen from the video title, an infinite random terrain generator. Now, disclaimer, it's not truly random, of course, which is never going to be the case unless you apparently use a quantum processor, which I do not have. So what we are going to do today, we are going to randomize our world, because let me take a look at how it looks now. I probably need to say npm run or npm install first, because this has no it hasn't got a node modules yet. And there it is. Okay, cool. So while it is installing, let me just go over. So we got to create a world something like this, right? And also we have some blocks. So let me just grab the thickest, fattest. Yes, okay. So we have some blocks. These are dirt blocks, okay? So these are dirt blocks. And these dirt blocks are pretty random because we have this layer of dirt that's right below the grass layer. And then right under that layer are going to be some random dirt blocks. And the same is going to happen with the bedrock layer. So we have a bedrock layer, really thick bedrock layer, very, very nice. And then we have some random blocks right above there, as you can see in the real Minecraft game as well. So in order to do that, we are going to create a pseudo-random number generator, or rather PRNG. And we can pass in a seed with this PRNG, which is really useful because we are going to generate our worlds based on seeds as well. And next we are going to create a purlin function. And we are going to use that purlin into our noise function, which is going to generate two things. A noise map, which we are going to use later for stuff like caves and stuff like that. And it's also going to create a height map. Now the height map is the thing that's going to create beautiful terrain. So first of all, the pseudo-random number generator. What the pseudo-random number generator actually is a really extensive version from the example that I'm just drawing right here. So let's say we have a clock, right? So it's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means that we have this array. So let's then say our max value is 12, right? Do you agree? Yes. And then we have the step size from 7, and then we have the seed, which is currently going to be 3, okay? So what happens if the step size is 7 and the seed is 3? Well, it's just going to be like this. It's going to be 3, 10, 1, 2, 3, 4, 5, 6, 7, and then 7 again, and then 7, and then 2, and then 9. So basically what you get out of this array is the generated array, which is going to be 3, 10, 5, 2, 12, 7, 3, 10. You know, this already looks way more different than this one. I think I did a counting mistake somewhere, but whatever, it doesn't matter. What it does matter, that it's basically going to create random numbers, but not really random. So what if we put this PRNG on steroids, and instead of the maximum value of 12, we are going to have a maximum value of 2,147,483,647. Personally, I really don't know why this is chosen, but apparently it does well, so yeah, totally cool. Let's just build it. So let's go to our project and let's create a PRNG.TypeScript, and let's export this class. So then we have some errors, skipping optional dependency. Oh yeah, so let's just say npm run dev for this. example right here. It's going to open in our browser, and this is what we have right now. So let's just fix the player first, because the player is generated on the bottom of the screen. So let's go to world, then just say 62 here. Also, what I want to do, I think the player is moving way too slow for proper testing. So let's just put our Steve on steroids as well. Let's just say something like that, so it will not be an even number. Okay, so let's export our class PRNG right here. PRNG, which stands for Pseudo-Random Number Generator. So we have the seed in here, which is going to be the number, and then we have those variables, the m, which is going to be this value. See, m equals this value. Okay. And we also have a, which is going to be this value, a primitive root modulo. And let's just say constructor, and we can pass in a seed here, but the seed can be undefined, and it can also be a string. So what if the seed is undefined? Then we are just going to say that the seed needs to be this calc math random. So let's actually create that temporary seed value, because we are going to change the seed. If it's a string, we are going to convert the seed into an integer. So we got to create a temporary variable called s, and then in the end we will say something like this dot seed equals s, something like that. Not really, but also let's move this one here so we can adjust it actually if we want to. I'm gonna put that in a repository. And then I'm just going to say this that m equals that, and this that a equals that. Oh, whoa, I shouldn't remove anything here. Okay, so let's create the calculation function, which is a public function, so we can just always exit it from outside this class. And it's going to return a number as well, and it's going to do the following with this number. It's going to return math, it's going to round this number to an integer, and I'm going to say n multiply this dot m minus 1. So what's wrong with this one? This the calc equals. Okay. So here, what if the variable s is still nil, because the seed can also be undefined. So let's say two more checks. What if the seed is a string? We are going to check that like this, and then we can just say else. So if it's not a string, if it's an integer, then we can just say s equals seed. Really simple, like that. So what if it is actually a string? We can do something like this. We are probably going to fine-tune this a little bit later, but for now, yes, let's just keep it simple. Let's just say seed.length here. So this is the case when we put in a string, and then we say n plus equals seed char code at I. So it's going to iterate through the seed. For example, if it is GML touch, then it's going to iterate through these letters, through these characters, and it's going to grab the character code from G, and it's going to plus equal that at n. And then it's going to say that the s is this calc n. So it will go through this one again, and it will round it up real nice. So what if the seed is out of bounds? So if it's outside this .m, if it's outside this range, then we got to pull it back into the range. So we can do that by saying this, and then we can say if this .seed is smaller or equal to 0. So if it's negative or 0, then we can just say this .seed plus equals this .m minus 1. So it will stay in the range again. Okay, so to check this, if this works, let's go to our chunk. Let's import those that PRNG, and let's just say private PRNG is a PRNG type PRNG, and then here I will say this dot PRNG. I'm gonna pass in the seed, so I can say new PRNG, and then the seed is just going to 1, 2, 3 for this matter, and then here I can say console log this dot PRNG, and I'm gonna go here. I'm gonna go to inspect, and I get some errors here, and the errors are gone. Not really. Infinite mesh batch u. Oh, I imported something automatically that's not being used. Okay, so we have the seed, which is really nice. We have the function ready to be generated. Okay, cool. So what we can do with this later on is we can create a function called next, and then it will outperform the math.random, because this one is, for our game, it's truly random. Like, even this function is not truly random, but this is based on the, probably, I think it's based on the date time. But for our game, this is not going to be good enough, because this will mess up a lot of things. So we are just going to create a custom function right here. Why don't we do that right now? So we can just say public next, because we are like going through the next iteration, some sort, like a little bit, kinda. Okay, and then we can specify a min or a max. So if we only put one parameter in here, that's going to be the max value. If we don't put anything here, it will just return a value between 0 and 1. And if we say min and a max value, then it's going to be returning a value between those two integers. So this one can be undefined, and it's going to be a number. If it's not undefined, and same goes for the max variable, and it's also going to return a number. And of course this is a function, so we got to do this. And why is this? Oh, because it's not returning a number now. So let's go to the let's go adjust the seed right now. So this is seed, and then multiply it by this dot a, and then this dot m. Okay, cool. Okay, so we can actually do this here as well, which will make it a little bit more random. So we can just do that right here. We can also put this in a function as well. So we can like say public shift, and it will return a number. And then we can just do this. And for this one and this one, we can just say this dot seed equals this dot shift, right? Cool. So let's create a temporary variable for the min. Let's check if it's undefined as well. But let's just say that it's going to be min or max. Now let's check if it's undefined. If it's undefined, min is going to be 0. Because if we don't specify anything, min is simply just going to be 0. Okay, what if max is undefined? So if we don't specify a max, then that will be probably the case, because we specified a minimum value, which is min or max. So then we can just say min equals max and min equals 0. Okay, so here, what if min still equals 0, or if max is still undefined, or max equals 0, or if max equals 1. What we are going to do then is we are simply going to return this dot seed divided by this dot m. So we will get a value between 0 and 1 here. Now, what if min equals max? We don't want that. So then we are just going to return this.seed divided by this.m, but it's going to say plus min. So basically, if we put in like 200, it's going to return something between 200 and 201. So what if min is larger than max? So we don't want that because max should be min and min should be min. No, max should be max and min should be min. Yeah, so that's why we created a separate min variable here, and that's why we called this min or max. So we can do that right here. We can say that the min or max is going to be max, and max is going to be min, and min is going to be min or max. So in this case, we just switch the min and the max value. And if we did that, now we are going to return this.seed divided by this.m, which is the really large integer, and then we can say max minus min. This is the reason why we need to switch that, and we are going to say plus min, because otherwise these variables will switch, and that's not what we want. So let's test if this works. Declared. Oh, of course we gotta return. So actually we can just say this. A little bit shorter right there. We don't necessarily need to return anything since we're not processing anything, so we can just do that. So let's test if this works. Let's go ahead and say .next. And as you can see, we have a random value between 0 and 1, and it's always the same value since the seed is basically the same. So if we have the same seed, then the value is going to be the same as well. So let's put in a value like 0.5 or something. So now we have a random, like sort of random, of value between 122 and 200. Now, as you can see, this variable right here is constantly the same for every single chunk. So what we could do as well is we can go to the world here, and we can create that PRNG right here. So let's do that right in front of the chunk, PRNG, and we can say public PRNG. Then we can just say chunk. Let's just do that right here. So this is now the place where we are putting in our seed, which is not yet created. And then we go to the chunk. So new chunk. Here is the data. And what we can do now is we can say PRNG. And then we can go to the chunk, and we gotta say PRNG, and we can do this. So now, if I'm correct, the values should change. And PRNG is not defined. Of course, we gotta say this.png here. And now we have some different values, all between 122 and what did I say? 200. So that's cool. This works. Now we can do that here to iterate between stone and dirts. But let's first of all start with some random terrain generation. So let me just copy the Perlin noise function I created on CodePen. Like this is, for example, one of the things you can do with Perlin noises. So we have a noise map right here. What we are going to use is we are going to grab one x value, like one y value, so we can create a height map. Okay, so y is always going to be 1 in this case. So let's just copy the Perlin noise function right here, the Perlin function. Let's copy it and let's paste it in a new script called Perlin.ts. Let's place it in. Make sure we export it. So export class Perlin. And then we can remove this one function. We can change this into the noise function, and then we can say that if we don't pass a y value in here, then y is always going to be 1. And yeah, so this returns a value, basically one value. So if you want to know more about Perlin, just look it up online. There are loads and loads of examples on Perlin. Wow, this looks good. What it is used for, it's used in different kinds of artwork as well. All sorts of games, as you can see. And there are also great tutorials online about more information. For example, a video tutorial for made by the Coding Train. Here another one. So really great examples. Here's the paper, because the function is made by Ken Perlin, and yeah, he created this function basically. So really great. Let's close all this. So let's apply that Perlin noise function to our game by creating another class called noise. And this noise function is going to be having a public static height map function, and this height map function, it's going to return a number array, and it will give an error because we are not returning a number array yet. And of course we gotta import our Perlin class here. So let's say Perlin from dot Perlin. Great. So here we have some parameters, for example the width of the array, so that's basically the array length. We are going to have an offset, so that means that we already did some steps in the future, so we gotta point where we need to start now. The steps we've already had go from there. And then we have a seed, which is basically the seed, and we have the scale, so we can scale our not our game necessarily, but more like the amplitude, stuff like that. Talking about amplitudes, and we are going to have frequency, persistence, and linearity as well, based on octaves. So persistence, and last one is linearity. Okay, great. So what we can do now is we are going to return our map. We need to create this variable, and let's initialize it as empty1. So here we are going to check if the scale is larger or equal to 0, because we don't want that. We want the scale to be higher, so then we just say scale something like that. So let's create a for loop here for the x-axis, because this one's only going to apply to the x-axis, because y is always going to be 1. And here we can just say iterate between 0 and the width. And here we have a few variables. One of them is height, which is going to be 0 at first, and the same goes for the frequency, but we are going to multiply with the frequency, so we can't multiply with 0 because then the outcome will always be 0. We gotta say 1 because that will not change frequency. Yeah, that will not change the result if we multiply something by 1. So let's create another iteration on our for loop, and this is going to be the octaves. So it's going to iterate based on the octaves. Okay, cool. So now we create a constant variable. This is going to be our x value, and our x value is going to be a number, of course, and it's going to be x plus offset. It's going to be divided by the scale and then multiplied by the frequency. And then we are going to pass that x value into a Perlin noise function, which we are then going to say plus equals to the height. So here we just say pass down the seed here, and then the x value as well, Then we are going to multiply it by the amplitude. And finally, we are going to multiply the amplitude by the persistence. And we are also going to multiply the frequency by linearity. Very good. Now we have created a height for this x position. So we gotta apply that or push that or add that to the map. And then we can safely return the map. So let's take a look if this all works. Let's go to our chunk and let's create, what's wrong with this one? PRNGs. Oh yeah, because we're not using it yet. We will right now. So let's create a height map property, and I gotta say public height map, and then I need to say number because it's a number array, and I'm gonna also initialize it as an empty one. And then right before we actually generate the world, we are going to say height map equals noise height map is noise, no, noise, yeah, okay. And here we gotta add the width, and here we gotta add the offset, which is this dot x, but it's going to be multiplied by this dot width. And then I wrote down some variables which are going to be useful. So actually you have the world seed right here, somewhere over here. Where is it? Did I add it here? PRNG, right? Yeah, so basically this is the seed, so we are going to add that to the game data or something like that, but right now I'm just going to hardcode copy this one and paste it in here to act as our seed. And then I wrote down a scale and the octaves and the persistence and the linearity. We can just change these values, but for now let's just keep it like this. And what we can do with this, we can apply that to the actual height. So this value right here is going to be between, I believe, between 0 and 1, maybe -1 and 0 and 1. But we need to multiply it with the actual amplitude, so, or amplifier basically. So let's create a height. Let's create a height variable, and we are going to say math round, and then we gotta get that x value, like the height, and we are going to multiply it by the amplifier, which we can also put in a game data, or we can base also these values and these two values on what biome we are at. Of course, we are going to implement that later. And what we can do now is we can check if it is lower or equal to the height. Otherwise, it's not going to do this. And let's do this as well. Height, like that. And what we can do now is we can also say, so if y is smaller or equal to height -1, but then in that case y needs to be higher than height -7 or something, and then we are going to make use of that PRNG. So we can just say, let's console log it first, this.prng next. Okay, so let's test if it works. So we can see that the random generation works as well perfectly. You can see that I'm having a bit of a lag. That is the case because I'm really having a fast player at the moment. Oh, I need to have the inspector open for that function to actually take effect. Okay, so as you can see, I'm getting FPS drops from 60 to 7 even, or 12, 10. So we don't want that, but in the real game, our player is going to be moving a lot less fast, so we have a lot less lag, as you can see. Okay, cool. So what we can do now, we can take a look at the console, because I didn't do that yet. and this is these are results from our prng.next. So what we can do now, we basically have a percentage right here. So we can choose when it's going to put a block or when it's going to put a grass or stone. So we can just say if is higher or equal, then the block name is going to be dirt for this x and y position. And there we have a bit of randomness, but watch this. I refresh and we have the same blocks on that same position. So that's really what we want. And we can do the same thing for the bedrock, which is non-existing right now. So we can add that as well. We can say if y, yeah, let's do that here. If y equals 0, then block name equals bedrock. So we gotta add that to our game. So I added a, oh, I didn't, so we gotta create that. Okay, cool. So let's create that 16 by 16. Let's make it beautiful black. Let's save it. As a bedrock. Then I'm going to show you how easy it is to add a block to your project. We just say stone, select the stone, change it to bedrock, and here have bedrock. And now it is an actual object in our game. So we can just say block name bedrock, and it's going to create block bedrock. And we have a bedrock layer at the bottom right there. So actually you of course want to use another block right there. But here you can do the same thing for like the other values. For example, if you want on 2 or on 1, so here you would say something like this, and on 1 there's a less chance, and here there's a larger chance, something like this. So let's go down, and we have something like this. Now of course it will be the other way around, like this. Okay, so now there's a 75% chance on bedrock on layer 1 and a 25% chance on bedrock on layer 2, and it's always going to be the same result. So thank you for watching, guys. We successfully created an infinite world generation. Tweak around with the values, and if you pass in a y value as well, we can even create a noise map for this one and do basically the same thing for percentages, stuff like that. And yeah, I'll see you guys in the next tutorial. Make sure to like, subscribe, hit me up on Twitter, and check out my Patreon page. And yeah, I really hope you like this tutorial, and you learned a lot from it. So that's basically my main goal here, that I teach you guys something. So I really hope it helps. I'll see you guys in the next tutorial. Ciao.